evening who actually are either students or staff from the University of Greenwich. My name is Christine Gorsden, and I am a lecturer at the University of Greenwich. I'm also a CIOB London Committee member, so I stand here this evening dual hatted. In the very first instance, I have to cover the domestic arrangements. There are no planned fire alarms this evening, so if you hear something, there are two alternative exit routes. Follow one of us. The muster point is on the grass outside. The muster point this evening is probably the pub in Greenwich. So, this evening we are delighted to welcome Mervyn Richards. Mervyn is the author of the BIM maturity diagram. Mervyn has an OBE relative to his services to industry relative to BIM. However, before we proceed with Mervyn's presentation, what we're going to do is we're going to give you a brief overview of London CIOB Novus Group. Whilst I am party to this evening's delivery and the presentation, this is a Novus sponsored presentation. So I'm going to hand to Chulu. Chulu is the current chair of Novus, Vic is the current vice, and Etienne is a committee member. We also have a student in our midst, one of our own, Sam Beardwell-Lacey, and he is a Novus committee member. So if there are any students within our audience this evening who wish to get more involved with Novus, please see any one of those guys on conclusion. I'm going to pass you right now to Chulu, who's going to talk a little bit about Novus to you.
Thank you very much, Christine, and thank you very much for everyone for coming this evening. I know you've taken time out of your busy schedules to come over, and that is testimony to how famous this topic is at the moment. It's being driven quite hard by the government to push it through. Our industry has always been a bit slow to catch up to technology, and these are some of the incentives which the government is trying to push in order for them to try and make our industry a lot more efficient and a lot more effective, cost saving as well in all the mix. So I'm pretty sure we're going to have a very good presentation later on. But I just wanted to take you through what Novus is. CIOB as a professional body has branches all around the country, and us being the London branch, and under the London branch, that's where we sit as the Novus Group. So this is a group of young professionals who actually meet up on a regular basis. We have meetings in London just to talk about current affairs within the industry. And pretty much what Novus is just a soundboard for all the students. It gives a sound introduction to CIOB for all the students. So what we do is that we go into universities, we give lectures to universities to try and steer students in terms of what direction they want to go with their careers. We support and encourage students in their progression all the way through university. So it would be from first years all the way to third years. We look after the interest of aspiring members, prospective members, the industry managers for the future. And what we do is to try and push everybody to try and see if they can actually move from being student members once they're qualified, whatever courses they're doing at university, to move on to ICIOB and eventually NCIOB. And there has been a little bit of a restructuring within the CIOB now, because we used to have grades, which is students, then from student to an associate member, then after associate member you become an incorporate member, then you become a full member. But what seemed to happen was that people were moving to incorporate member and they were not moving up to full membership. So what they've done is that they've restructured how the whole system works. So once you come from university, you move directly to a holding position for you to work your way up to full membership. And that's what we do as a Novus Group, to try and encourage all the students to push themselves into full membership. We offer fun and exciting CPD events, which one of them will be this one, being an event. But we do quite a lot of other events during the course of the year. Opportunities for students receive support from recent graduates. So if you become a CIOB member and a novice member, you get a lot of support from people who were literally on that side of the desk, pretty much. People who just qualified from being students. They advise other students in terms of writing dissertations, in terms of how they go about their assignments and all that stuff. Stand out from the crowd. So pretty much the industry is quite large, but at the same time it's quite small. You meet a lot of faces as you work within the industry. So what we try and do is get all the students and start engaging them into the industry, start having events where we invite the industry to meet the students, and the students have a bit of a feel in terms of what they're going to be experiencing once they get into the work life. Get recognised for future employers, which is pretty much what I've just explained, matching the employers and the students coming together in terms of pretty much just interacting. Take advantage of career and study guidance, which is what we do. There's a lot of libraries, an online library we have, where students can actually go into the library and they can make use of the information. And Novice is a group that steers you down that way. So whatever you're looking for within your assignments, we can guide you in terms of what you'll be finding in those libraries. Benefits of becoming CIOB member, I think they're pretty much self-explanatory. Career enhancement, potential for financial gain, recognition, professionalism, and that's what the CIOB charter membership is all about, is professionalism. So if a CV goes into an employer, the first thing they're going to be looking for is how qualified is this person. Then the next thing they're going to be looking for is what professional bodies can actually sort of back you in terms of, yes, he has the professional experience for him to do the job. There's a difference between academics and the difference between professionalism. Academics is pretty much you learning the theory of what you do and what the topic is. Professionalism is more about you engaging into that role and actually learning how to manage the system. So I think that's where the two differences are. And once you get to MCIOB, it's a mark of professionalism. So wherever you go, they'll look at you and say, okay, he's professional enough, give him a chance. Personal development as well, networking. Networking is quite a big part of us. So what we do is that we hold networking events where sometimes we don't even talk about the industry. It's just a case of coming together as people who work together and just sharing ideas. I'll hand you to my colleague, Etienne, who's at the moment working on the Battersea Power Station transformation. And he's going to take you through that to just give you a bit of what he does for his role.
Yeah, hi there, good evening everyone. My name is Etienne Leroux. I sit on the Novus committee, and whilst we are waiting for Mervyn, who is not too far away, I'm just going to tell you more about my job really. Thank you all for coming tonight with, like Julie alluded to, is a very hot topic at the moment. I work for a company called Turner and Townsend, and I work as a BIM project manager. Now, we're a global company with 90 offices around the world, predominantly project management and cost consultancy services. And we firmly believe as a company that BIM is going to completely, well, revolutionize the way we work in construction. And we are kind of spearheading the way we implement building information modeling on projects and integrating that into project management. So we believe that one day we won't be BIM project managers, we'll just be project managers again. The BIM will fall away and it will just be the way that we operate. So I currently work on Battersea Power Station. Those of you who will have gone over from Victoria Station on the train will have seen that there's a lot of construction work going on at the moment on phase 1. I currently work on phase 2, which is the actual power station itself. It was built in the 1930s, and at some point it actually generated 20% of London's electricity. So a mega station. It was then decommissioned in, I believe, around the 70s, and for a long period it became derelict. Loads of planning applications were submitted to try and turn it into all sorts of things. But a few years ago, a Malaysian consortium bought the Battersea Power Station, and they were granted planning permission to turn this, the whole area, not just the station, but essentially the whole area, as you can see from what it is today, to this whole new regeneration project. So the client is Battersea Power Station Development Company. The whole thing is divided into 7 phases, with phase 1 being the one that's being built at the moment around here, phase 2 being the power station itself, and then a few phases after that. And this whole development is being done in a BIM collaborative environment, the whole project, with a total value of about £8 billion, which will stretch up until 2025. So a major regeneration, which will also include the extension of the Northern Line, which is very complicated because we're already building, but we're having to dig tunnels and eventually build a new tube station that comes out right by the entrance of the power station. So very complex, and that's why we've decided to go down the BIM route. So just in general, I'm just going to fly and talk you through the things that we use BIM for, and I'm going to try and not step on Mervin's toes here, because I'm very sure that he'll tell you exactly what BIM is about in terms of the management of information. But BIM isn't just 3D modeling. BIM is really much more than that. But it starts out with a model. And essentially we started off with a 3D model and turn it into this virtual environment. And the clients are now able to put augmented reality goggles on and actually look at their asset whilst they're standing in it. So for instance, if you were the client, you could stand there and say, well actually hang on, maybe we should make the atrium bigger because there's not enough light coming through. Or maybe we should put the coffee shop on the other side and move the stairs, which is very hard to visualize when you're just looking at 2D drawings. So straight away there's a massive benefit there for the client to see and visualize what it's actually going to look like. So once you've done that, at the same time you can carry out some what is called thermal imaging or thermal modeling. So obviously this big building is not very thermal efficient at the moment, so you do a laser scan, and based on that you can recreate a new 3D model, and we can exactly work out where we need to put all the insulation to make this building as energy efficient as possible. We also carried out pedestrian simulation, which uses algorithms to put a certain amount of people in the model. And you can run a simulation, for instance, an emergency event, and you can start a fire here. And through algorithms, the people will start running away and kind of predict how we would normally behave as human beings. And that way you can see whether the footpaths are maybe too small, whether there's a bottleneck, and you can see how quickly people are actually able to escape from that zone. You can make the doors wider, you can add new doors, and just simulate so many different things. And then, as I mentioned, obviously very, very, very complex project with lots of tunnels and piles going underneath, and I truly believe that we couldn't have done this without actually modeling this in a 3D environment, with all these tunnels going across, and we've picked up many, many clashes that wouldn't have been resolved during the design phase if it was done in a normal 2D process on drawings. So then we move on. This is obviously not happening yet, but this is in the phases to come. The contractor will then obviously come on board. He'll use the model as very much this collaborative sharing environment where he takes the model and he connects it to programming software. So instead of having just a normal Gantt chart, you can actually physically link every object in the model on a program. And you can put a crane in there, you can put trucks and all sorts. You can put the whole site set up there in terms of logistics. You can exactly work out where things are going to be, whether the crane's actually going to reach. You can manage transport in and out, and see in real time how the building is being built before it's actually built on site. So by simulating the build process in a 3D environment, you can actually see, well, hang on, you won't be able to get this piece of steel work up here because in the program we've already said that we'll be doing, we'll be putting scaffolding up there. So you can rearrange the project and say, well, actually, we need to get the steel in first and then put the scaffold around it. So this is obviously a continual process, and eventually we believe, which is probably unlikely at the moment, but we believe that we want to get rid of paper in the industry, in the construction industry. So the people who actually install the components on site won't be walking around with a drawing and saying, okay, well actually I'm supposed to, as an electrician, put the light here and there, looking at a 2D drawing. But you'll actually have an iPad with you, or whatever, a tablet device. And you'll be able to walk around in the model and see exactly where that light's going to go. Whereas perhaps in a 2D environment, you wouldn't see how far the light is off the ground, and whether you need a scaffold tower. You can actually simulate all of that. So the tradesmen are actually using the 3D environment to carry out their work. And then once we've actually built the whole asset, it gets handed over to the facility managers, or the asset managers. And they can then look at the asset and say, well, we've got our plant room running, and there's a pump that's overheating. That's linked to a dashboard in a control station. And it will send a signal and flag it up and say there's a problem in the plant room, whether it's a pump, it could be a leaking pipe that sends a signal that says there's a leaking pipe here, and straight away you can call in the facility team or the maintenance team and say this is where the problem is, this is what the problem is. You can come in, they'll have the right tools at the right time to carry out the right job straight away. So constant monitoring. And I think just the last one, in terms of just carrying out routine maintenance over a sustained period. If something needs replacing, whether it's a light bulb or you need to repaint the roof, the guys carrying out the actual maintenance of the building, they'll be able to interrogate the model long before they need to carry out the works, and they'll be able to again see what tools they need and how long it's going to take, whether they need specialist equipment to come and carry out the work. So really, that is a very broad picture of what we believe BIM is. It's not just a 3D model at the start, but it's very much about creating information, design information, which carries on into construction information, over into asset information, and we can reuse that information to build new assets going forward. So it informs the client to be more intelligent and manage his portfolio better. So yeah, thank you very much for listening. I see Mervyn has just turned up, and I will hand you over to him in just a second. Thank you very much.
Yeah, thank you very much. Like Etienne was saying, BIM will definitely revolutionise our industry. I was working on Crossrail myself not too long ago. Crossrail is using BIM. And an example I use is when they were actually digging the tunnels through Tottenham Court Road, and they had where they had to squeeze it through a few tunnels. They call it the eye of the needle. They had to use 3D modelling and had to use BIM to do that. On the other side as well, when you build the tunnels in Crossrail, there's a lot of M&Es that go outside the tunnels, and you can't every time be removing the panels in order for you to actually access all the information. So what Crossrail has done is every piece that's being installed is tagged, and that tagging is on a 3D model so that people can actually go back. It could be maybe 10 years from now. They could literally go back with either an iPad, and they'll just click on that and you'll tell them where the fault is, and they'll just remove that one panel. These days we have a situation whereby if they have to remove something, they have to remove all the panels in order for them to access something. So I feel like that's the direction we're going. We just tried to power up Martin's laptop, so once that is powered up, I will definitely go to the main event. If you like.
While we're waiting for that to get going, first of all, my apologies. We have all this technology and all these wonderful things we can do. Unfortunately, the ticket seller at St Albans Station forgot to tell me that London Bridge is now closed for some period of time. So I've actually been down to Haywards Heath, which is quite a nice place if you don't know. So it's taken me a little time to get back. So thank you very much for your patience, and I hope it's going to be worthwhile. I'm sure it will be. Adventure. First of all, phones up. Mine, not yours. And as always, technology is part of the main problem in any of these things we do, because the cable mismatches or something similar. We'll get there.
This guy seems really cool. Oh. Sorry, can I see that? Can I see that?
Indeed. And while he's doing that, one of the interesting things, of course, one of the documents that's been drafted is security. So So is your machine secure, and can anybody get your retrieve your information without the password? Obviously you can. So failure right at the beginning. I heard the end of what was being said about Crossrail and this requirement, hopefully, once we build the asset information models, and the asset information model meaning a true representation, a handover of what was actually constructed, not what was designed. But what was constructed with all defect and deviation, so that as we move forward we can use some of the new technologies, augmented realities, Google Glasses, whatever, and I think we suggested we could walk around, look at the ceiling, take out the appropriate panel, find everything that we need. This is something that we are aspiring to, because at the moment it's a bit of a mixed bag. I'm finding on a couple of contracts that the interpretation is I've got a wonderful 3D model, I've got a great 4D model, and my as-built will have all of the A4 documents telling you what the defect and deviation was attached to it. Not updating the model, so the Google Glasses and the ability to use augmented realities on that particular project is going to be a total waste of time. It's a halfway measure. So we do have to be careful looking at what are our aspirations in all of this and managing our way towards those aspirations, as opposed to what some people tell us they're doing from a PR point of view, but in reality, not really moving towards that requirement at all. And it is something I just wanted to mention because I find this everywhere I go. Because of the need to market to one another, how wonderful we are, we have a tendency to over our abilities or what we do, which gives the industry a misunderstanding of what's actually there at the moment. One of those is, which we will look at, is looking at BIM level 3, which is really good. So many people now tell me they're already at BIM level 5, which is really good, because we haven't actually written down and defined what BIM level 3 is yet. Part of this problem is that the vendors try to get us mixed up. So you can actually do this certification course with one of the main vendors looking at BIM level 1, BIM level 2, BIM level 3, BIM level 4, BIM level 5, etc., which has got absolutely nothing to do with what Her Majesty's Government's strategy for BIM is. So there's a bit of confusion out there in the industry when people say, I'm a BIM level 5. And then we have to have a conversation to what you actually mean by that, and try to make sure we all understand what we're talking about. Words are the biggest problem in communication when we're trying to collaborate with one another. 3D modelling to you is possibly something totally different to what 3D model is to me, which may be totally different to what somebody else thinks. And the term model is also a very confusing problem. It is not a 3D physical model. The model, as we will see, is actually all of the information that's required to complete the project, hand it over and deploy it. So it includes the 3D model, all of the asset information data, and any document, even a video showing us how to repair something, any other information that is pertinent to the operation of that building. That is the model. The model in this sense is the best interpretation, the best bunch of information that we can actually provide. So in the early days we used to talk about single model environments, which has also came to confuse everybody. Because when we actually coined that in 1994, we couldn't actually build a 3D model. Unfortunately, by the time we reached the end of that period, of course we were doing 3D modelling, so everybody thought, single model environment, I built my single model. No, it didn't. We had to change the terminology, I'm going to show you now, to the common data environment. Because the term model meant an environment, the best possible environment we could give you to collaborate with one another. So having said that, I'm wasting a bit of time to get to the presentation, and at this point I usually get a bit confused as to what key I'm now going to touch, so I'll just touch anyone and see what happens. Okay. So first of all, who am I? You know who I am, I think. My name is Mervyn Richards. I'm a lecturer here at the University of Greenwich on a number of occasions, and I also lecture at other universities as well, particularly on the subject of BIM level 2. So very specific as to what this discussion is about. BIM, which is the horrible acronym that we've unfortunately adopted or had thrust upon us by the vendors, has moved away from what we were actually trying to achieve in the first place, and it's also caused a division in our industry. Because BIM is used in the defensive mode by the infrastructure users as something that only builders do. Because it's building, information, modelling, or in my terms, information management. So I don't have to do that because I am different, I do this in a different way. Everything that has been produced and has been written up in the British standards was developed on infrastructure projects. It was on railways. In general, it was on the M25. It was on very large buildings project, shall I say. Because I don't quite know where a civil engineering project finishes and a building begins. It's an interesting definition. So I put B red here, danger. We don't really want to talk about that. And you will find in most of the documents, the government documents, 1192 series of documents, the term BIM has almost been eradicated. In fact, it will be at the next turnaround. What we are talking about is information management. And that means all information that's related to completing the design, the construction, the handover and the operation of the particular product or project. And while some people think that BIM is locked into that 3D world with a bit of data attached, believe me, this is only the starting point. Because BIM will actually encompass everything we do within our industry and within our organisations. It will be attached to the back office. So if we look at the back here, business systems, construction management systems, design planning, etc., etc., etc. It's all about the logistics, the delivery, the sign-off of the delivery. Did I get what I asked for? Was it delivered on site? Yes, it has. I can pay for it. We already have contracts and projects where people have RFID tags on their uniforms in the morning. We know who's going on the site. We know who's coming off it. First of all, implement it because this is good management to make sure that everybody has got off the site, and we are looking after people in the event that they fall down a hole and nobody's seen them. Well, that's usually the reason for putting it there in the first place, but it's also linked after that into the payments and everything else. So information management in its total sense eventually will be linked as just part of the business process, and the information for running our business in construction, for operating the product or the project, and also giving the information to the organisation that is actually using that building to operate its business. So a long time ago, before this acronym was ever thought of, a long time before the first CADD machines, everybody thinks it all started with CAD. It didn't. It started with CADD, computer vision CADD 3, 2, 3, 4, etc. Was about computer-aided design and drafting. And the reason for that was that the machines in the very early days cost about £60,000 a seat, and I was being paid £1,000 a year. So I now need to be 60 times faster than I was with a slide rule and a pencil or pen. Impossible to achieve. So we had to think of a different way of using these technologies. And the reaction of this was we started to write new types of programs, which is where we're really going to for level 3, a different type of software solution. What we had to do was to write programs where we carried out the design, let's talk about structural design in the simplest form, or highways, because that's been there since 1965, where we could actually set in our alignments, we could do our vertical alignments, we could generate 3D images of those highways, we could print them in 2D or we could print them as 3D images. Right way since 1965. This is nothing new. But the action was do the design, produce a model, get all your drawings, your materials and everything else out. And that's what makes the whole thing leaner and faster. What happened to all of this was in 1989, the industry collapsed, 30% of the industry was put out of work, and 1991-92, the work started to pick up again, and design houses and the construction offices found they no longer had space to put the people in a drawing room with a long working table. At that precise moment, as always with these things, the PC arrived, and a cheap piece of software from America called AutoCAD to do 2D drafting. So although we've been working since 1972-74 on 3D, we suddenly had to throw it all away and go back to 2D drafting. So all of those ideas of models and information driven from a design process disappeared, and we've had to wait until the industry and the software has got back to where we were 30 odd years ago. And whether you believe that. It started with a guy called Nicholas Negroponte. It does go back a decade before that. But Nicholas Negroponte wrote a book called The Architecture Machine, a lot of research at MIT, which basically showed, they wrote the programs, they had some very interesting phosphorus machines, screens that they worked with, but they could show how the computers could be made to carry out some analysis of the building and make and help architectural decision making, particularly on areas, juxtaposition of areas and things like that. And they could also get areas and things out of it, so leading them towards very basic cost management. So Nicholas Negroponte, has anybody ever heard of him? No? Well, he's still there today. His family is very big in American politics, and he's also the guy that set up a few years ago a computer for everybody in Africa, or at least every child in Africa. If you know the guy now. So he's out there, he's done the thing, he's changed the way he works, he's changed his politics to some degree, and he's still there and still thinking of these things. So here is a 3D model of process plant work.